Assalamualaikum. We are from Group Zenan and this is our video for mathematics projects matrices set B.
And I'm Allis, and this is
Wafi.
we will be solving KY question by using Adzreen method.
Next, Adzreen will solve the K2 matrix by using the ERO methods.
And I'm Miza, and Farah will solve the K3 question using the ERO method too.
So this is how to solve K1 by using adjoint. So first we take out 5 from row 1 column 1. So the cofactor we just ignore the row 1 and column 1. So we get this and put into the matrices 3 times 3 and continue with the A12, C12 and until A14, C14 like this. So for the first cofactor we put into the bracket 3 times 3 matrices. So to find cofactors we take out 2 just similar like matrices 4 times 4. So we use formula AD minus BC by close row 1 column 1. So we get 1 times 4 minus by 5 times 8. So we get negative 36 here. So as well for the second row we close first row and second column. So we get 1 times 4 minus 5 times 4. So we get 1. So continue to the next steps until we get all these cofactors. So after we times AD minus BC, so we continue get 1 by 1 cofactors and solve the problems until we get the determinant for K is 84.
After we got the determinant which is 84, we need to find the cofactor for each number in K1.
This is the cofactor that we got from the K1, and we need to multiply the cofactor with the determinant which is 1 over 84, and this is the answer for the K inverse. Next, we need to multiply the K inverse with the P, and this is the answer after we multiply P and K inverse.
So next, this is how to solve K2 by using ERO.
So I was given the second question, which is also 4 by 4 matrices, which is that is the question, which is K2. So the question asked me to find the inverse of these matrices. So in order to find the matrices first, the inverse we have to know the determinant first. So in order to find the determinant, we have to find the value of these matrices. So we convert it into a 3 by 3 matrices, just as it is, and then we convert it to 2 by 2 matrices in order to use the formula which is AD minus BC. So in order to use the formula, we use the formula which is A which is 1 multiplied with 4 and then minus with 3 multiplied with 3, and then we do the same for the second column and the third column until we get the value of negative 6. Then we use the same formula for the second, third and fourth matrix. So we get the value of negative 2, negative 4 and negative 2. So after we get all the value for these matrices, we have to put it back inside the 3 by 3 matrices in order to find the value of the determinant. So what actually is determinant? So determinant is a value that tell us if matrices have inverse or not. If the determinant is 0, which means the matrices is singular matrices, it doesn't have any inverse. So we can never convert matrices into an inverse if the determinant is 0. So after that, we substitute the value is at the 3 by 3 matrices, which is 1 multiplied with negative 6, negative 1 multiplied with negative 2, positive 1 multiply with negative 4 and negative 4 multiply with negative 2. After that, we calculate the value, and what result I get is 0, as you can see, like this. 1 multiply with negative 6, negative 1 multiply with negative 2, positive 1 multiply with 4, and negative 4 multiply with negative 2, and I get the value which is 0. So it proves that this matrix doesn't have any inverse on it.
So this is how to solve K3 by using ARO.
This one is the matrix of K3. So we will find the inverse of K3 by using the ARO method. First of all, the origin matrix will multiply with the matrix identity, which is this one, as you can see. Next, the R1 will multiply 1 over 4 to change the R1. So after we do this one, we get this one, and R2 minus 5 R1 to change the R2, R3 minus 3 R1 to change R3, and last one for change the R4, R4 minus 3 R1. So after we do this one, we get this. So R2 multiply 1 over 4 to change the R2. So we proceed the matrix. After we get this one, the R1 minus 3 over 4 R2 to change the R2, and R3 minus 11 over 4 R2 to change the R3, and the last one R4 minus 11 over 4 R2 to change the R2. So now I will pass to Miza to continue the ARO.
Thanks to Farah. Then we proceed to the next step. When we are settled with the minus and multiply operation here, we will get this one. We got the whole number, and then we proceed to the next step to let for the row G to let this become 1, and which is we will change row G with row 4, and then the row G we will multiply by negative 1 to get the positive number for row G. And then we proceed to the next step, R2 minus R3, and so that we get the R2, and R4 minus 2 R3, and then we get the R4, and we will get this, and then we will left with the last row, which we will change the negative 9 into 1 by using this equation, which is R4 multiplied by negative 1 over 9. Then we will get R4, which is 1 here, and then we proceed with the next number following this number. Get this number. And then the last one, we will change the row 1 using R1 minus 3 R4, we will get R1, and then R2 minus 7 R4, we will get R2, and for R3, we will plus with 10 R4. And then when we finish the step, we will get this answer here.
Using the method of P, which is this one, we'll continue with multiply both of this. This one is based on the latest answer just now. So both of these will multiply each other, and then we get this one. This is the answer of the multiple of this.
So this is the meaningful message that we got, which is as per shortnya agro.
So, as a conclusion, for K1, we didn't get the answer because the number is too big and didn't match with the code. And for K2, we didn't get the answer because the matrices can be inverse. And we only get the answer in K3, which is as per shortnya agro.